Alright guys, today we're looking at another form of linear equations. So yesterday we looked at slope-intercept form, right? So what I want you to do first is plot this graph, y equals negative 1/3 x plus 4, using what you know from last lesson, pause, and then come back. Alright, I'm assuming you've done that. The y-intercept of this graph is 4. And the slope is negative 1/3. Remember, a slope just describes a change, so you need a place to start. That means we've got to plot our y-intercept of 4 first, which we will do. There's our y-intercept of 4. And then it's a negative slope, so remember that means we need to go one negative motion, one positive motion, so we can go down 1 and right 3 from that point, and we could do that as many times as will fit. Or we could have also gone up 1 and left 3. Or you could do both. I usually just like to fill it out with as many points as I can, really, especially when I'm doing this on the smartboard. And make sure you put arrows on the end to show that those solutions keep going on forever. So hopefully you got that. We're going to look at a different form of equations today, and that would be point-slope form. Just like slope-intercept form gave you the slope and intercept of a line, point-slope form gives you a point on the line and the slope. Okay, so the format looks like this, and if you want to kind of see what this looks like with actual numbers in here, you can kind of look ahead at B. And see what that would look like with actual numbers in there. So in place of y1, x1, and m, you'll have numbers. So again, whatever number is here, m is the slope, and the point on your graph is going to be at x1, y1. Okay, there's a couple things that you're going to want to pay attention to. First, remember that the x-coordinate comes before the y-coordinate in an ordered pair. Okay. However, in this equation, the x-coordinate is coming second after the y-coordinate. Okay, so you kind of got to keep that straight. So x1 is coming from here, y1 is coming from here. The other thing that you have to realize is that those subtraction signs are supposed to be there. Okay, so that means if you have subtraction signs there, x1 and y1 will both be positive. If you have addition signs, that's when they would be negative. So let's take this next one as an example, and I'm going to show you exactly how to use this. So you're going to use this the exact same way that you used slope-intercept form. You're going to find the point and the slope of the line. You're going to plot the point first because you need somewhere to start, and then you're going to use the slope to create more points. Okay, so first things first, my point on my graph is 2, 1, coming from here and here. Notice it's not negative 2 and negative 1. It's positive 2 and positive 1. Okay, the way that I like to remember it is if I plugged in a 2 for an x and a 1 for y, I would get 0 equals 0 for the equation. I would get a true equation of 0 equals 0, which means that point must be on the graph. Okay, so you're thinking, what do I put in for x to make the right side 0? What do I put in for y to make the left side 0? That's kind of another way to think about it. But again, if you just look at the formula, the minus signs are supposed to be there. Okay, so you shouldn't get a negative. Okay, you should not get a negative for x and y unless there's a plus sign. My slope is 1/2. That's coming from over here. So I need to plot the point 2, 1 first. That's right here. And then I need to use my slope of 1/2, up 1 over 2. Or down 1 and left 2 would also work. Make as many points as you want, connect them with a straight line. So it works very, very, very similar to slope-intercept form. Again, we had to plot the point 2, 1 first. That was really, really important that we did that because, again, you can't use a slope from just anywhere. It's got to be from a point already on your graph. So I want you to try the next two on your own. Pause and then come back. Okay, I'm assuming you've done that by now. Here, the point that we know is on our graph is -3, -2. Here we do need negatives because they're supposed to be subtraction signs, but instead they're plus signs. So the way that you could think about it is, well, if I were to change this to subtraction, it would be -2 and -3. So my x has got to be -3 and my y's got to be -2. My slope is -3/2. So I'm going to start at the point -3, -2. That's right here. Then I'm going to go, it's a negative slope, so I got to make one negative motion, one positive motion. So I can either go down and right, down 3 and right 2, or I can go up 3 and left 2. Again, connect them with a line. Make sure you put arrows on the end. Again, make sure you are plotting the point first. You can't use the slope from just anywhere. It's got to be from a point you know is on the graph. Okay, last one. Hopefully this one was pretty straightforward except for the slope. The point is 6, 4. That's right here. Slope is -5. Remember how we deal with slopes that are whole numbers? We put them over 1 and make them into a fraction. So from there, we can go down 5 and right 1, or we could have gone up 5 and left 1. Connect those with a line, put some arrows on the end. That's it for point slope form. Point slope form is really not particularly tricky, so hopefully you got that. Hopefully practice stuff goes well.